Last video of Unit 3 for Pre-Algebra. If you're joining us just on YouTube, note that our entire Pre-Algebra course is available or is going to be available here on YouTube for free. You can click the link in the iCard to get there. If you're just one of my students ready to get to some math, in this video, we're going to be talking about adding fractions with unlike denominators. I teach what I call the butterfly method to get a like denominator. And the reason I teach this this way is because it always works. Now, you can think about this as figuring out what the least common denominator is by finding the least common multiple between the denominators and all of that jazz. And that absolutely works and even is shorter on some problems. The reason I teach this method pretty much exclusively at this level of math is because it always works and it requires less thinking, which means less confusion. And so that's the reason why we do that. So let's see what I mean by the butterfly method. Here we go. We're going to dive in like we often do, especially at this point in the year, just by heading on with some examples. So let's do that in this video too. Example 1 is going to be 3/5 plus 1/3. All right. So we don't have a common denominator because, newsflash, 5 is not the same as 3. I know, it's heartbreaking information here. So what we're going to do is we're going to butterfly, right? That's where we're headed, and that's what we going to do, right? So the first thing we do is make the first wing of the butterfly by going like that, blapo. That's a beautiful wing. It's gorgeous butterfly. Absolutely gorgeous. And we multiply along that wing. So 3 times 3 is 9. Right? Then we're going to do the next wing of the butterfly and do 1 times 5. 1 times 5 is 5. For the last bit, we need to know what the denominator is going to be. In order to get the denominator, what we do is we multiply the two denominators together, right? So 5 times 3 is 15. 9/15 plus 5/15. Now we got a like denominator. Now it's just like the last video that we did, the last lesson that we did. So 9 plus 5 is 14. We keep the denominator the same, 14/15. That doesn't reduce. Bob's your uncle, unless he's not. And then Bob's not even my uncle. I don't have an Uncle Bob. Do you have an Uncle Bob? Anyway, that problem's finished. Easy peasy, right? Let's do another one. Let's do another one. How about example 2? -5/6 plus 1/8. Okay, so we're going to butterfly. We've got to make sure the sign follows where it belongs, right? So 5 times 8. 5 times 8. We've got negative. 5 times 8 is 40. Bring down that plus. And then the other butterfly wing. 6 times 1 is 6. And then to get that last one, we're going to follow the same sort of plan, and we're going to multiply right there. 6 times 8 is 48, right? Now, I'm going to note this. If you've done this before, you might have just said, well, couldn't we just make the denominator 24 and multiply the 6 times the 4 and 8 times the 3? Yes, you could. And if you know how to do that, and you're one of my students especially, you are welcome to do it that way. I'm not going to tell you can't, not at all. We're just using this because, again, it always works and it requires a little less thinking. In this case, it's going to have us practice some reducing later, which is all good. Right. So the signs are different. We're going to subtract. So 40 minus 30. I almost gave away the answer. 40 minus 6 is 36. The bigger one is 40, right? So it's negative 36 over 48. These reduce. They're both divisible by 12, so we're going to divide the top and the bottom by 12. So, LOL, JK. I don't know if you noticed the little stutter there, but the reason was because I realized that I had made a mistake, and I knew I'd made a mistake because what was going to come out of this answer was not going to be what was in the notes that I have for this. And so I knew I'd made a mistake, but I wasn't seeing it right away, and so I had to pause. I chose to pause instead of remaking this entire video because that would have been no bueno. So, yeah, so I told myself 3 times when I was doing this that 40 minus 6 is 34, not 36. I don't know why 36 was, well, because of the 6, right? But, yeah, so how about 34? So I was going to divide by 12, but that doesn't work, does it? So what we're actually going to divide by is by 2. We're going to divide the top by 2 and the bottom by 2. And we're going to end up with negative 17 twelfths. 24ths. Now I'm stuck on 12, huh? There we go. That's no big deal, right? So let's do one, mixed numbery one, and then we're going to be done, and we'll be done with this unit. So, example number 3. Example number 3 is going to be rhyme not intentional, but kind of fun anyway, I suppose. 9 3/5 minus 7 2/3. Okay. So what I like to do is kind of pull these fractions out, get the common denominator, and then go back and stack the mixed numbers like we've been doing, like we did in the last video for, and borrow if necessary, all those things, right? So we've got 3/5 and 2/3. All right, so we're going to butterfly these guys. So 3 times 3 is 9. And then 5 times 2 is 10. And then for the denominator, we multiply. 5 times 3 is 15. Okay. So now we're going to take those and going to put it back in our stack, right? You might want to do this you can do this in scratch paper space, or you could do it right in the problem as long as you keep it neat. Either way, right? So it's going to be 9 9/15. Uh-oh, some of you may have already noticed we're going to have to borrow. Oh, no, we can handle it, though. Minus 7 10/15. Okay, so we got to borrow because we can't take 10 away from 9. Can't even do it, right? So we're going to turn this 9 into an 8. And then we got to borrow over here. Remember, when we borrow with a mixed number, we add the denominator and the numerator together. So 15 plus 9 is 24. Right? So then we just subtract. Subtract the fraction part and the whole number part. 24 minus 10 is 14. 8 minus 7, 14/15, right? 8 minus 7 is 1. It's positive. We've got the positive on the top. Bigger number is positive. All the things. 1 14/15. That's it for this unit. Thank you, guys. If you're not one of my students, then thank you for joining us. This entire pre-algebra course, the lecture part anyway, is available for free here on YouTube. If you want to see what else we're doing, you can check out emberlearninglabs.com. If you are one of my students, do your homework. We'll see you in class. Thank you, guys. Have a great day. Bye-bye.